are going to see about the semiconductor electronics. So in the heading of semiconductor electronics, we are going to discuss so many topics. The first one is introduction, second one semiconductors, third one why semiconductors are so important, and third one is the band theory of solids. The next one, types of semiconductors. In the types, we are going to discuss about the intrinsic and extrinsic semiconductor. So first of all, we are going to see about the introduction part. So from the name itself, semiconductors. So we are having the meaning in the name itself, semiconductors. Partially it can conduct current. So before the discovery of this semiconductors, we are using this vacuum tubes. So the vacuum tubes, which consists of two things, that is anode and cathode. And there are so many drawbacks of vacuum tubes, such as it is so bulky, the size is very huge, and the voltage that we have to apply is very high. So we need a high voltage to apply for this vacuum tubes, and the low reliability of this vacuum tubes are the demerits of which has been fulfilled by the advantage of this semiconductors. So after the discovery of semiconductors, so we can say it revolutionized the field of communication in all sectors. For example, in communication, it revolutionized so many things such as the computers and laptops and the TV, that already in the olden days we are using this CRT, this cathode ray tubes. The TVs have been replaced by the LED TVs. So if we take a space field, the space sector, we can take the Chandrayaan and Mangalyaan, so many satellites we are launching. So these semiconductors, they can play a vital role in that also. So in each and every day that we are using the electronic gadgets, so in all the electronic gadgets, we are having the applications of semiconductors. So now we are going to see about that semiconductor only, which plays a vital role in our day-to-day life. And what is semiconductors? So semiconductors are the materials whose conductivity lies between the conductors and the insulators. So what is the conductors? Conductor is a material which can conduct the current. For example, you can take we already know that it is a iron, copper, silver, and so many examples for all the metals. Mostly they are comes under the category of conductors. And what is insulators? Insulators is a material which do not conduct the current. For example, you can take a glass, a diamond, or plastic, wool, and so many examples for the insulators also. So why we already discussed about the uses of semiconductors. Why the semiconductors are so important? Why we are giving the preference to the semiconductors? So in semiconductors, we can control the number of charge carriers. Charge carriers here, the electrons and holes. So easily we can control the charge carriers, the movement of electrons and holes. And also the current we can give us a unidirectional. There is only one flow. The current can be controlled in only one axis or one unidirectional axis, we can say. Next, we are going to see about the band theory of solids and what are the structures inside the semiconducting materials. So before going to see that, we are having the two different bands going to discuss. That is valence band and conduction band. So what is a valence band? Valence band, it consists of the valence electron. So this valence band is always completely filled orbit, and this electrons cannot be contribute for the current conduction. So we have to keep it in mind. So this valence electron which are present in the valence band do not contribute for the current conduction. So next one is conduction band. So the electrons are present in the conduction band only, they can contribute for the current conduction. And this conduction band is not fully filled, it is empty, or otherwise it is a partially filled one. So next one, which is called as the energy gap. What is this energy gap? The gap between the conduction and the valence band is called as an energy gap. So this energy gap is always called as a forbidden gap. So this band gap is given by noted by Eg, which is given by the formula. We already know the formula for energy formula. E is equal to h nu. So h nu is equal to c by lambda. So we can write as h into c by lambda. And next one, we are going to discuss about the types of semiconductors. So there are mainly two different types of semiconductors. The first one is intrinsic and the next one is extrinsic. How we classified that is depending upon the purity and impurity. So what do you mean by impurity? Impurity means it is not as a dust or anything. Here we are adding an extra element. So that process is called as a doping. We can call it as doping is a process by which we can add the impurity to the material. For example, extrinsic is purely it is based on the doping process. So we are adding an extra element, so it becomes an impure one. It is called as an extrinsic. Whereas if we take intrinsic, it is a purest form. There is no addition of extra elements, third elements to that. So in the extrinsic, we are having again we are classifying into two different types depending upon which element we are going to add it. So it is N type and P type. So this N type and P type depending upon which type of valence element that we are adding. So N type it is depending upon the pentavalent. So penta means 5. So 5 valence electrons or the material which is having 5 valence electrons like a phosphorus, arsenic, they are being added. So whereas if we take a P type, it is a trivalent. So which is having a 3 valence electron. Material which is having a valence electron of 3 are being added, which is called as a P type material. So now let us see that intrinsic semiconductor in detail with the help of energy level diagram also. So in intrinsic, it is example for semiconducting materials is silicon, germanium and so many materials are there. So if we take a silicon which is having a 4 valence electron. So what happens is this silicon and the 4 valence electrons, what it does is at temperature at absolute 0 or 0 Kelvin, what it does is it can form a covalent bond. Covalent means a sharing of electron. So the covalent bond with the neighboring this silicon atom. So what it does is it does not take part in the current conduction at 0 Kelvin. So what happens when the temperature is increased? So when I increase the temperature, what it does is this electron, it can be removed from this orbit and the holes are being created. So what is mean by a hole? So what is mean by these electrons are removed from this bonding and the holes have been created. Holes are the positive charge carriers. These electrons are the negative charge carriers. So these electrons and holes are called as charge carriers in semiconductors. So these electrons can take part in the current conduction when the temperature is being increased above this 0 Kelvin or absolute 0. Thereby this valence, that way the creation of valence electron can be possible for the current conduction in intrinsic semiconductor. So with a clear concept we can explain in the energy level band diagram. So in energy level we already discussed about this. This is a valence band. This is a conduction band. The lowest band is called as a valence band and the higher level band is called as a conduction band. So at 0 Kelvin we can say that all the electrons are being filled in the valence band. So already we know that the valence band consists of completely filled or partially filled electrons. So it is completely filled with electrons at 0 Kelvin and there are no electrons in conduction band. So there is no electrons in conduction band is there is no possibility for current conduction. So in this situation what we can say that this semiconductor it can act as an insulator. So we can call it as insulators at 0 Kelvin. So semiconductors at 0 Kelvin it behaves like an insulator, that is a non-conducting material. So what it happens is when we increase the temperature. So when the temperature is being increased above this 0 Kelvin, what it does is it can gain energy. This electrons in the valence band it can gain energy, and what it does is whenever electrons are being excited, it can go to the higher orbital level. So the higher orbital level is conduction band. So what it does is these electrons are being moving towards the lowest level of the conduction band. So lowest level of conduction band it can occupy and thereby creates a holes. So these holes are called as a positive charge carriers. These electrons are called as the conduction band electrons. These electrons only they can promote for the current conduction in semiconductors. So how many electrons are being more in the current conduction band? It permits for more conductivity. So here the number of electrons is equal to number of holes created. So holes are the vacant places or it's a positive charge carriers. So how many electrons are being shifted to the conduction band, leaving the number of holes in the valence band. So in this case the number of electrons is equal to number of holes, or concentration of electrons is equal to concentration of holes which are being created in the valence and the conduction band. Next we are going to discuss about p-n junction. So we already discussed about the p-type and n-type material. So these p-type and n-type material are being joined together. It makes a junction which is called as p-n junction. So if you take a p-type material, you are having a majority charge carriers or holes. So positive charges are being in p-type material. If you take a n-type material, so here the majority charge carriers are electrons. So more electrons will be in n-type and more holes will be in p-type material. So these being joined together, it makes a junction diode, which is called p-n junction or diode we can say. So if this, in this question, so if we give the external electric field, what happens to the electrons and holes? So we are going to see that. So in the presence of electric field applied, so what happens is, so we know that this electrons are being moving towards or diffused towards this positive charge carriers. So these electrons which can diffuse into the layer which is called as a depletion layer, the thin layer which is formed between the p and n junction, which is called as a depletion layer. So this depletion layer is very thin. So within a very short period of time, what happens is this depletion layer, it grows. So and it consists of the immobile ions. We can say that it is an immobile. There is no movement of ions. That is positive and negative charge carriers. So this layer is called as a depletion layer. So if we give the reverse bias, so this depletion layer region is very wide. So here, so what happens is the negative charge carriers, that is the electrons are being formed nearer to the p-type, that is hole region, and the positive charge carriers are being created nearer to the electron region, that is n region. So here what happens is a potential junction barrier is being formed with a potential difference of about 0.1 to 0.3 volt difference. So the current which has been created due to this process, which is called as a diffusion current, because these electrons and the holes, they are being diffused into the layer. So the current being generated or produced is called as a diffusion current. So this p-n junction is a very basic or fundamental aspect in semiconductors. If you understand this concept of p-n junction, so let us be going for the semiconductor, that is the p-n junction, they can take an output which is called as a semiconductor diode that can be applied for example, we are using a LED lamps. Nowadays all the houses are being ordinary bulbs are being replaced by the LEDs. So this diodes, that is semiconductor diodes, which can play a vital role. So this is a symbol for a diode, that is it's a positive, that is a negative sign. So if we have a arrow mark in the above that of this positive, which is called as, if the arrow mark is there, we can call it as an LED. Okay, light emitting diode, we can call it as a light emitting diode. So this p-n junction, if we take this for external application purpose, we can call it as a diode. And this LED, the same, the p-n junction diode aspect is for the light emitting diode. Next we are going to see one problem. So what is given in the problem is one circuit is given. So in that 4 voltage is given and the resistor and the LED. So the current which can flow through the LED is also given, that is 20 microampere. The potential difference across the diode they asked to find out. So we know the formula for Ohm's law, V is equal to IR. So the potential drop across this is given by V is equal to IR. The I value is given in the problem itself, that is 20 microampere, and the R value is 15 ohm. So if we multiply it, we can get 300 microampere. So micro means 10 power of minus 3. So we can get 0.0003 volt. So here it has been asked to find out the potential difference across the diode. So this is the potential drop. So across the diode has been found by subtracting the two values of 4 and the calculated value of 0.0003 volt. So totally it's approximately, the value is very less, so it is being nearer to 4 volt itself.